Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, in this video we will discuss about the total energy possessed by a body in a vertical circular motion. Might be the body is at any position, what highest, lowest, midpoint or any other positions. What will be its total energy, that we'll discuss. Hello students, let us discuss about the total energy in vertical circular motion. Total energy in vertical circular motion. Now, if I have a particle moving in a circle and this is at highest point H point, this point is suppose the lowest point, this point is suppose the midpoint, and this point is any point P. If I find the velocity at different points and see what is the result, and the result will be that it will be same, because it is a conservative field and the total energy has to remain same. Obviously we neglect few things, but then without considering the average distance, the total energy will remain the same. At the highest point, the total energy is the sum of kinetic energy plus potential energy. The kinetic energy is half m velocity at this point square Vh, which is under root of gr. So squaring Vh square, that is under root gr, plus the potential energy is mgh, and h is this height from this point. This is the reference line. This height is r plus r, that is 2r. If I add them up, 2 mgr, half mgr is 5 over 2 mgr. This is the total energy at the highest point. Okay, so this is the total energy at the highest point. Now let us say what is the total energy at midpoint, that also we'll find. So let us find that. Total energy at midpoint. The total energy at midpoint is kinetic energy at midpoint plus potential energy at midpoint. The kinetic energy is half m Vm square plus potential energy mgh. The Vm minimum value is under root of 3gr, squaring it is 3gr plus mgh. H is how much? The height of that point from the bottom line, that is from the lowest point, this vertical distance, which is equal to the radius of the path, r. You can see here this 3 by 2 mgr plus mgr. So this is 2 plus 3, 5 by 2 mgr. So the total energy at midpoint is no different than the total energy at the highest point. The total energy at the highest point was also m by 2 mgr, here also m by 2 mgr. If you find the total energy at the lowest point, then also it will be that. Let us find that. Total energy at the lowest point. The total energy at the lowest point is the sum of the kinetic energy at the lowest point plus the potential energy at the lowest point. The kinetic energy at the lowest point is half m velocity at the lowest point square plus potential energy mg height of that point at the lowest point. Half VL at the lowest point, we have known that it is under root of 5gr. Squaring it is 5gr only plus mg into 0 because at the lowest point the LH value is 0, height is 0, so it is 0, and then it is 5 by 2 mgr. So be it any position, the total energy will remain same. Though we have specifically found the total energy expression for only the lowest point, midpoint and highest point, we can also find the total energy to be same at any other positions also. So we find the total energy at any generic point. So let us find that total energy at any generic point. Suppose that I have a circle like that and a point is here which is not midpoint, lowest point or highest point, any point which is making an angle theta with respect to the vertical. At this point the velocity is suppose P, and I want to find the total energy over here. The total energy at point P is sum of the kinetic energy at point P plus the potential energy at point P. Kinetic energy is half mv square, half mvp square, and the potential energy mgh. Bp square, already we have got the expression for Bp at any position. It is gr 3 plus 2 cos theta that we have already derived in our video. So you can use directly this value here, and what I am getting is half m, squaring this it is gr and 3 plus 2 cos theta plus mgh. What is that h? H is the height of this point above the ground or above the base lowest point. This is this height h, and already we know that if this is your r, then this is your r cos theta, and this whole length is r. From r you subtract this r cos theta and you will get this one h. So therefore h is r minus r cos theta. Now I'll just open the bracket and I'm expecting that it should be the same as 5 by 2 mgr that we have got so far. So let us try that. This is I'll just open all brackets. This is 3, so this is 3 by 2 mgr. This one with this one, it is mgr cos theta, because 2 will cancel. Here it is mgr, with this it is minus mgr cos theta. If you see properly, then mgr cos theta is plus here, mgr cos theta is minus here, this will 2 will cancel out. This is 3 by 2 mgr, this is mgr, so 2 plus 2 is 4, 2 here, I'll write 2 here, 2 plus 3 is 5, so it is 5 by 2 mgr. So for any point, generic point, we see that the total energy will remain the same, is not going to change. This is the expression for total energy at any point P. Thank you.